Hello and welcome to our lesson on radicals, factor trees. First of all, let's talk about the definition. Prime factorization occurs when you break down a number to the prime numbers that were multiplied together to create that big large number. And remember, a prime number can only be created by multiplying 1 by that number. And these are some examples. So the only way that you can come up with the number 1 is by multiplying 1 times 1. The only number that you can come up with by 3 is 3 times 1. The only way you can create 5 is 5 times 1, and it keeps going. 19 times 1, 23 times 1, and there's lots more prime numbers. But those numbers can only be made up by multiplying itself and 1. Those are primes. Now, how do I factor down to those prime numbers? In order to do the prime factorization, you have to create a factor tree. So let's start with the number you're trying to break down, which happens to be 40. You can pick any numbers you want that multiply together to get 40. In the end, you're always going to end up with the exact same prime numbers. So randomly, I'm going to take 4 and 10. You could have chosen different numbers if you wanted. 4 is not prime, so we have to break this down. And look, 2 is prime, and so is the other 2. I put little dots under the prime numbers so I can keep track of where they are in my tree. 10's not prime, so I can break it down to 5 and 2. 5 can't be broken down any further, and neither can this 2. So I have all these prime factors now. 2 times 2 times 5 times 2. Now, since we discovered those prime factors, we need to show our answer as one long multiplication problem. So we had 2 times 2 times 5 times 2. Now, you need to double check your answer. All you have to do is actually run this multiplication problem. And if your answer equals your original number, which should be 40, we hope, you've done it correctly. So 2 times 2 is going to be 4. 4 times 5 is going to be 20. And 20 times 2 is 40. And oh, look, it matches. So that means our prime factorization was done correctly. All right, let's try a couple more. Let's try to factor prime factor 24. You could do 6 times 4, 8 times 3. 1 times 24 isn't going to help you any because it's the same as 24. So randomly, let's do 8 times 3. 3 is a prime factor. Now I can break down 8 into 4 and 2. 2 is another prime factor. 4 is not prime, so I have to go further. And there's my 2 and my 2. Now let's double check. 2 times that 2 is 4. 4 times 2 is 8. And 8 times 3 is going to be 24. It matches. So those numbers right there, 2 times 2 times 2 times 3, that's the prime factorization for the number 24. Now let's look at 54. Again, you can break it down however you want to. I say 9 times 6. Let's try that. 6 isn't prime. We can break it down into 2 and 3. Both the 2 and the 3 are primes, so we don't have to go any further. 9 is not prime, so we can break it down into 3 and 3. And those are prime numbers, so we're done with those. So it looks like, we're going to double check. 3 times 3 is 9, times 2 is 18, and 18 times 3 goes right back to 54. This is how it should work. So you would write the answer 3 times 3 times 2 times 3. Okay, it all went back up to 54. All right, on the next one, we're going to try 2 more. Let's look at 35. We can break it down into 7 and 5. And look at that. 7 is a prime number, and so is 5. You're done. That's the only way to break those down, so it's just 7 times 5. Those are both prime numbers, so you're finished. How about 64? You've got 2, because 2 can go into the even numbers, and 2 is going to go into it 32 times. Now 2 is a prime, so we can stop with that, but 32 is not prime, we still have to break them down. So let's do 8 times 4. 8's not prime, got to keep going. 4 times 2, I just found a prime number. 4 is not prime, so I have to keep going. And I just found 2 more prime numbers. And this 4 up here has to be broken down further, and I've got more prime numbers. So it looks like our answer should be 2 times another 2 times another 2 times another 2, times another 2, and then times one more 2. So we'll put it right there. Now let's see. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. And 32 times 2 is 64. So it worked. We got it correct. Now, as a quick review, in order to find prime factors of a number, you have to create that factor tree, where I did that kind of upside down V shape. And then you keep breaking down those numbers that come off of there until you have only those prime numbers left. Remember, prime numbers are numbers that can only be divided into by 1 in itself. To double check, you take all your prime numbers and you just multiply them together. If you did it correctly, your answer should lead you back up to your original number that you were trying to factor. And that's it for our lesson on radicals, factor trees.